An aroma, potent and fleeting, is a ghost of the tangible world. It can evoke memories, stir emotions, and transport us across the chasm of time. But what if we could resurrect the very scents that filled the air of ancient civilizations? What if we could inhale the perfumes of pharaohs, the incense of Mesopotamian temples, or the fragrant oils that adorned Roman aristocrats? This is the tantalizing promise of Paleo-Perfumery, a burgeoning field where archaeology, chemistry, and history converge to decode and recreate the olfactory landscapes of the past. This journey isn't just a frivolous indulgence. Fragrances were deeply embedded in the spiritual, political, and social fabric of antiquity. They were used to commune with the gods, to project power and status, to heal the sick, and to navigate the intimate rituals of life and death. To resurrect these scents is to gain a more visceral and multisensory understanding of our ancestors. The human love affair with fragrance is as old as civilization itself, with evidence dating back over 4,000 years. In ancient Mesopotamia, the world's first recorded chemist was a woman named Taputi Balata Kalam. Her name is immortalized on a cuneiform tablet from around 1200 BCE. An overseer of the royal palace, Taputi developed groundbreaking methods for scent extraction, including using solvents to create lighter, more enduring fragrances. Her recipes, fit for a king, included a complex blend of flowers, oil, calamus, cypress, myrrh, and balsam, which she distilled and filtered multiple times. Ancient Egypt is perhaps the civilization most synonymous with perfumery. For the Egyptians, scents were the literal sweat of the sun god Ra. Priests, the first perfumers, would burn copious amounts of incense, believing the fragrant smoke carried their prayers to the heavens. But the Egyptians' mastery extended beyond the temple. The hot, dry climate made scented oils essential for moisturizing and protecting the skin, and perfume was a clear marker of high social standing. The Indus Valley Civilization, flourishing around 3000 BCE, also had a rich history. Excavations have unearthed terracotta distillation apparatus, and early Hindu Ayurvedic texts describe the distillation of ittar, a natural perfume oil, primarily for royalty and religious ceremonies. In ancient China, scent took a different form. The Chinese primarily used incense, burning aromatic woods and resins to perfume their homes and clothing. They also carried sachets filled with dried aromatic materials, guided by the Taoist belief that extracting a plant's fragrance liberated its soul. The art was further refined by the ancient Greeks and Romans. The Greeks, learning from the Egyptians, had philosophers like Theophrastus document the art and science of perfume making. For the Romans, perfume was an integral part of their lavish lifestyle. They used fragrant oils in their famous baths, scented their public spaces with sprays, and even had perfumed water flowing in fountains. So how do modern scent sleuths unearth the chemistry of these ancient perfumes? The work begins once an artifact, like a pottery shard or a perfume bottle called an unguentarium, is unearthed. The challenge is immense, as organic molecules are notoriously fragile. But with highly sensitive analytical techniques, it's now possible to identify these chemical fingerprints. One of the most powerful tools is gas chromatography mass spectrometry, or GCMS. This technique is incredibly effective at separating and identifying the individual chemical components of a complex mixture. A tiny sample of residue is dissolved in a solvent and injected into the gas chromatograph. The sample is vaporized and carried by a gas through a long, thin tube. Different molecules travel through the tube at different speeds depending on their chemical properties. This separates the mixture. As each component exits, it enters the mass spectrometer, which acts like a molecular scale. It bombards the molecules with electrons, breaking them into charged fragments, and then measures the mass of these fragments. This creates a unique mass spectrum for each component, which can be matched against a library of known compounds. While GCMS is great for smaller molecules, it's not suited for large ones like proteins. This is where paleoproteomics, the study of ancient proteins, comes in. Proteins are the building blocks of life and can tell us what types of animal fats or plant oils were used as a base. Like DNA, the sequence of amino acids in a protein is genetically determined, allowing scientists to identify the specific plant or animal source. This is particularly useful, as many ancient perfumes were made with a base of animal fat, such as goose fat in ancient Egypt. Of course, the analysis is fraught with challenges. The degradation of molecules over thousands of years is the most significant. Exposure to water, oxygen, and microbes can destroy the very molecules scientists are looking for. Contamination is another huge problem. Distinguishing original molecules from those absorbed from the burial environment is a critical and difficult step. Furthermore, many ancient recipes call for ingredients that are now extinct, making modern recreations a difficult puzzle of finding the right substitute. Despite these hurdles, paleo-perfumers have had remarkable success. Let's look at some key discoveries. Ancient Egypt, with its well-preserved tombs, has been a treasure trove. When Howard Carter opened the tomb of Tutankhamun in 1922, he found over 3,000 unguent jars. Analysis of one revealed a base of neutral animal fat and a resin. More recent analysis suggests the primary fragrant component was spikenard, a rare and expensive aromatic plant from the Himalayas. Its scent is a complex and profound mixture of sweet, spicy, and musky notes. Another famous Egyptian fragrance is kaifi, a compound incense burned in temples. Recipes are inscribed on temple walls at Edfu and Philae, listing up to 16 ingredients, including myrrh, frankincense, honey, wine, raisins, juniper, and cinnamon. The creation was a lengthy, ritualistic 12-day process. Researchers like Dora Goldsmith, an Egyptologist specializing in the archaeology of smell, have recreated kaifi based on these ancient texts. Goldsmith also collaborated with historian Sean Coughlin to recreate the Mendasian perfume. While no Egyptian recipe survives, Greco-Roman texts describe its ingredients as myrrh, cassia, and resin in a base of balanos oil. Their work resulted in a fragrance with a spicy base note of myrrh and cinnamon, and a sweet undertone, a scent that remained stable for at least 2 years, a quality for which Egyptian perfumes were renowned. One of the most significant discoveries was a massive perfumery on the island of Cyprus. Located at Pyrgos Mavaraki, the 43,000 square foot factory dates back to around 2000 BCE, making it the oldest known large-scale perfume production center in the world. It was a sophisticated industrial complex with distilling stills, mixing bowls, and funnels. Residue analysis of pottery has identified the scents of lavender, bay, rosemary, pine, and coriander. And remember Taputi, the Mesopotamian chemist? A team in Turkey spent 3 years meticulously translating the Akkadian text and experimenting with her methods. The tablets revealed not only her ingredients, but also her advanced distillation techniques, and even a ritualistic aspect, noting she worked under a full moon. Their successful recreation is a direct link to the olfactory world of ancient Mesopotamia. Finally, in a Roman tomb in Carmona, Spain, archaeologists discovered a 2,000-year-old perfume in a sealed quartz unguentarium. Chemical analysis revealed a base of olive oil and the unmistakable scent of patchouli, an oil from India. This was significant, as patchouli wasn't thought to be common in the Roman era, suggesting the tomb's owner was a person of very high status. The perfumes of the ancient world were a testament to vast trade networks. The most prized ingredients were often exotic and expensive, traveling thousands of miles. The incense trade route was a network of land and sea routes, linking the Mediterranean with the southern Arabian Peninsula, the source of frankincense and myrrh. For centuries, caravans of camels, laden with these resins, would travel from modern-day Oman through Yemen and Saudi Arabia to ports like Gaza. The kingdoms that controlled this trade, like the Nabateans with their capital at Petra, grew immensely wealthy. The palettes of ancient perfumers were rich and varied. Resins like frankincense and myrrh were the undisputed kings. Flowers like roses, jasmine, and lilies were popular in the Roman world. Spices like cinnamon and cassia brought warmth and sweetness. Woods like sandalwood and cedar were highly prized. Herbs and roots added complexity, like calamus in Mesopotamia or spikenard in Tutankhamun's tomb. And while less common, animal products like goose fat were used as a base, and musk from the musk deer was used in some Chinese fragrances. The process of recreating an ancient perfume is a delicate dance between scientific analysis and historical interpretation. Researchers like Dora Goldsmith and Sean Coughlin use experimental archaeology, meticulously researching ancient texts, from Egyptian hieroglyphs to Greek medical treatises, to understand the methods. Coughlin's project, Alchemies of Scent, is a 5-year effort to reconstruct Greco-Egyptian perfumery. The team treats each recreation as a scientific experiment, documenting different variations to understand the underlying chemistry. This isn't without debate. Ancient texts are often vague. The identity of Balanos oil in the Mendesian perfume, for example, is disputed. Some say it's from the moringa tree, others from the desert date. Researchers test multiple interpretations to address these ambiguities. This work has given rise to a new subfield, sensory archaeology. This approach seeks to understand the past through all the senses. By reconstructing the smellscapes of ancient cities, archaeologists can gain a more holistic understanding of ancient life. An ancient city would have been a complex tapestry of smells. The aroma of baking bread and sizzling street food would have mingled with the stench of open sewers and animal waste. The air in a Roman city would have been thick with the smells of charcoal fires, dampness, and food processing. The study of these smellscapes reveals much about ancient societies, from sanitation and public health to cultural values, like the sprinkling of rosewater in Roman theaters. It challenges the traditional view of ancient cities as monumental but odorless spaces. The field of paleo-perfumery is still in its infancy, but it holds immense promise. As analytical techniques become even more sensitive, it may one day be possible to identify the faintest traces of ancient scents. The increasing interest in sensory archaeology is also likely to lead to new ways of presenting the past to the public. Imagine walking through a museum exhibit and not only seeing the artifacts of ancient Egypt, but also smelling the kaifi that was burned in its temples, or the spikenard that was used to anoint its pharaohs. This kind of multisensory experience has the power to create a much deeper and more personal connection to the past. The work of paleo-perfumers is a reminder that the past is not a silent, colorless, or odorless place. It was a world of vibrant sensory experiences, a world where the scent of a flower or the smoke of incense could hold profound meaning. By resurrecting the lost sense of antiquity, we are not only satisfying our curiosity, we are adding a new and vital dimension to our understanding of the human story. The ghosts of ancient aromas are all around us, waiting to be awakened, and the dedicated scent sleuths of paleo-perfumery are leading the way in this fragrant and fascinating quest